Good evening, and thanks for joining. It's another day that we want to start, or we want to continue with our machine learning uh, course, short course introduction. All right. So, please, if you have any questions pertaining to the previous work, you can let me know. If not, then we can move to today's section. Thank you. So I have given you just a minute or two, just to tell me anything. If not, then we can start with today's class. Thank you. If you cannot talk, then you can send a message in the message box, okay? Briefly. Okay. Since silence means consent, then I'll move to today's class. Thank you, everyone. Today we are starting our introduction to machine learning, and we would like to ask ourselves, what is machine learning all about? This is just an introduction. Yes, because it's a lot. As you can see from the picture, you have a lot of sections, a lot of divisions. So an introduction will help us to survive for future works. So basically, machine learning, as you can read from the screen, is a subset of artificial intelligence that enables computers to learn from data and improve their performance on a task without being explicitly programmed for every specific cases. So instead of following hardcore hand-coded rules, machine learning algorithm identify patterns. So there are some keywords we will take note in this particular session. So patterns make predictions or decisions based on data they are trained on. So where did machine learning take its root from? You see, so remember the regression that we did, you know. So we the regressions basically is use previous data. So that is training data. Okay. Then we make predictions in regression. So in machine learning too, we make predictions in machine learning after it have learned on the data. Now in the learning on the data, there are patterns. It learn the patterns, then it make predictions, and decisions are based on that for future works. All right. So when you look at the diagram carefully, you realize that we have artificial intelligence, machine learning, neural networks, and deep learning. So deep learning comes under neural networks, and neural networks also come under machine learning. The machine learning comes under artificial intelligence. So it's in that order. But in all, holistically, they are referred to as data science. They are referred to as data science. So in data science, we have all these branches. But so it means that if you're understanding somebody can specialize in machine learning only. Someone too can also specialize in neural networks, and someone also can also specialize in deep learning, and some too on artificial intelligence. So these are the subdivisions. Right. Okay. So when somebody is an expert in data science, it doesn't mean that he have command on all these. No, it's too broad. It's not easy to cover all. It means that he or she has specialized in one particular area. He or she has rather specialized in one particular area. So that is brief introduction to machine learning. Now, key aspects that we have to consider under this is the learning from a data. So the model have to learn from a data. Then after learning from the data, you have to predict. You have to do some predictions. So the same story is on regression. So if you understand regression very well, as we did the other time, you can also understand machine learning very well. Just that machine learning, why do we call it machine learning? Why? We'll get to know soon. I don't want to give that information now, but it is so interesting. So then we have decision making, then we have automation. So we will first consider the first two, that is learning from a data, and then we'll come to the prediction. For decision rule, is also another big area on its own. Automation is also another heavy one on its own. So we are only concentrating on the first two. Okay. Now, even the first two, it's some certain areas, right, that we are going to look at. It's just a short course, so no problem. All right. So this is just a brief introduction, and then I would like to move on to the next phase. If you have any questions, you can put the questions in the message box, or you can raise up your hand and then I'll call you, or I'll allow you to talk. Thank you. All right.
Hello, Doc.
Every Emmanuel, yes.
Okay. Please, thank you. I have a question.
All right.
So, can it be said that one is a subset of another?
Yes, it can also be said like that. One is a subset of the other. Yes. For example, uh, deep learning is a subset of neural networks, and neural networks is a subset of machine learning in that order. And machine learning is a subset of artificial intelligence, and artificial intelligence all come together to give us what we call data science. So in a subset form. So what it means is that if you know what they call deep learning neural network is not a problem. If you know neural networks, learning machine learning is not a problem in that order. Okay. All right. So Efia, thank you. Any other? Okay. So I think we can move. So key aspect of machine learning. So we have learning from the data. So what's the core idea here? The core idea is to feed algorithm large amount of data so they can learn patterns and relationships. So uh, patterns and relationships. So these are the keywords. Then prediction and making of decision. Once trained, the model can predict outcomes and classify unseen data. We'll get to know what the meaning of unseen data. Now, still on decision making, it's about selecting an appropriate category or action based on the data set. So after learning, we predict. Then after predicting, we make a decision. Then automate. Machine learning automate tasks that traditionally require human judgment and expert. So automation, you have already programmed it and then you are giving it a command to do it. So it's also another huge area. All right. So we want to venture into the types of machine learning. Basically, we are looking at three, but in our study, we'll look at only the first one. So you have supervised learning, unsupervised learning, and reinforcement. Now, when we talk about supervised, what are we saying? With supervised learning, the model is trained on labeled data. We'll get to know what the labeled data is. So you can be putting some points down, like when you say labeled data, meaning each input has a corresponding correct output. Spam detection in email. So the data values are labeled and they are in rows and they are in columns. So that is another example for supervised learning. All right. Unsupervised learning, the models work works with unlabeled data to find hidden patterns or groups. So customer segmentations. So that is unsupervised. And then reinforcement. The model learned by interacting with the environment and receiving feedback. So example is robotics. So uh, based on the environment, the model learns and begin to work with it and then give you informations. Someone will ask, which areas can we apply this? Which areas can we apply this? Application of machine learning, we can use speech and image recognitions. So that's very, very important. Fraud detection. So this one, the bankers like it so much. So they are employing a lot of artificial intelligence and the machine learning experts for fraud detection. So the CIA, in the US, UK, now a lot of machine learning experts, they are there. That's why they're able to track each and everybody who is dealing or trying to fraud someone bank account or something. Yes. Then medical imaging diagnosis. This is one area that I'm also working on. So we are able to use machine learning to, sometimes you go to the hospital and then they'll ask you to go and take an X-ray. Brain surgery, brain tumor, chest X-ray, and I'm sure most of you have gone to the hospital for this X-ray kind of thing, and they printed the thing out. You only just watch it, but you ask them how you can interpret it, you don't know. But when you take it to the doctor, the doctor is able to pinpoint exactly what is wrong. Now, machine learning is doing all those things because it have learned on previous data. So the moment those X-ray, what they call it, plate is inserted or the picture is captured into the data set, we can use it to diagnose exactly what is wrong. So people are really working on that. And then uh, autonomous vehicle, okay. So we have vehicles, all right. So automatic vehicles, we are using all machine learning to do that. And then we have some recommendation systems. That's Netflix and Amazon. They also have machine learning is being used or is applied there. Now, the speech and image recognition is, for example, when you talk about speech and image recognition, translation is one. Machine learning is doing all that. Then image recognitions, for example, your face identity. Okay, nowadays all the schools, when you scan your face, then the gate will open for you to enter. So all these things are all machine learning tools. Or we use machine learning in doing that. Advanced form. All right. So I would like to move on to, okay. Now, in our case, we are looking at data sets for machine learning. All right. We are looking at data set for machine learning. And now the method of splitting the data, since we are dealing with data, for us to work with machine learning, we have to split the data. So we split the data set into training and testing. So the data is split into two, but not equally. One will be bigger than the other. So we have what you call the training data set, and then we have what they call the testing data set. So so we train the model with the training data set. Then we do the prediction with the testing data set. I'm taking that portion again. We split the data into two parts, but not equally. The percentage depends on your research, but we have a default one that scientists or experts in the field have specified. But depending on your particular ratio, you can change it. Okay. So we have what you call the first part is the training. Now the training is the one that the model will learn on it. Then the testing is the one that after learning, you go and test on that one. Now with the training, when the model learns, it have learned its patterns, its everything, skills, everything in the data, plus or minus everything. So we don't use that training to test again because it already knows that principles, the principles there underpinning those training data. Then when you use a new data set, that is the testing data set, that is what we call the unseen data because it doesn't know it for the first time. You are now bringing it to test. So we call it the unseen data or the testing data set. So the model will now learn on that one. And then based on the errors or based on some computation that it will give, we can just and then begin to see if the model is good or not. So perform prediction using the test data set, that is unseen data set. Then how do we judge if the model is good? So we do what we call evaluation. Evaluate how well the model generalize. So how well is the model doing? Now the above is a proper machine learning workflow. So this is basic machine learning workflow for real data set. Okay. All right. Now, three main ways of splitting the data. Oh, I said three is four. Sorry. Four main ways of splitting the data set. Four. So we have the training testing split. That's a common one. Then we have the k-fold cross validation. That's also another one. Then we have stratify splitting. Then we have the last one, hold out method. The hold out method. So these are the splitting. The splitting is very, very, very important. In fact, you splitting it into two, not equally, though, is a major, is a great achievement. Like you have solved most of your problems. All right. So correctly, that's when you do it correctly. Okay. If you have a question, you can send a message. If not, we can proceed. All right. Gifty, please, you can speak.
Please, I would like to know if the splitting of the data is dependent on the specific type of work you are doing.
Please come again.
Is the splitting of the data
Mm-hmm.
based on the specific type of work you are doing?
Exactly.
Okay.
It is based on the specific work you are doing. Okay. Yes. Any other? It's similar to using the p-value. You know, the default p-value that we use is 0.05, or let's say the 5%, right? But in health, don't go by the 5%. Sometimes they go by 1% because they say the 5% is too risky. Okay, so we compare it to the p-value. So the p-value changes based on what you are looking for. So the same thing applies to the splitting. All right. Thank you. I think with this, I can move on to the next phase. So how do we split? Method one, splitting and testing. So splitting, testing, and or let's say training, test, and or whatever. So description. Divide the data set into two parts. One for training the model and the other for testing its performance. And how does this work? So the splitting, normally we say 70%, and then for the training is 70%, and for the testing is 30%. If you go for 80% for the training, it means that 20% will be for the testing. All right. I think I made a mistake here. It should have been 30 to 20, but so that the 70 will move with the 30, and then the 80 will move with the 20 in that order. Now, the model learned from the training set. All right. So the splitting, as we said, we can say 70% for training, 80%, no, 30% for testing. All right. Then, or we can say 80% for training, 20% for testing. So they are not equal, but in normal way, the training is higher than the testing. Yes, because the model have to learn a lot before coming to predict. Yes. And vice versa does not apply. No. All right. So what are the advantages? Simple and fast. So this particular method, the first method is very simple and is very fast. Good for large data sets. So it's good for large data sets. Then what are the limitations? The evaluation depends heavily on how the split is made. So it depends on the evaluation, depends on how the split is made. So you make sure based on your research, you know how you're going to split the data set. All right. So this is the first one. It's so easy, not difficult. All right. I would like to proceed to the next phase. Okay, so k-fold cross-validation. So with this one, the data set is divided into k equal parts. So maybe you want to divide the data set into 5 equal parts. All right, so 5. The model trained on k minus 1 folds, okay, that is one of the, and then test on the remaining one. All right, so maybe it's 5, the model is trained on, you have the data set and you have divided into 5 equal parts. All right, then 4 of them, you use it to train the model, each of them. So you pick the first part, you train it on a model, you pick the second, the third, and the fourth. Then after that, you now test each of the model on that one sample that is left. This process repeats k times so that each fold is used once as a test set. So that's why we call it the k-fold cross-validation. So it's more or less a validation process. All right. So that's basically what k-fold cross-validation is. It's very, very useful. And we shall see how it works. All right. Advantage: provide a more reliable estimate of model performance. Reduce variability caused by a single trained data set. All right, because you have trained different, just a model on different data sets, and you are using each of them to test on one particular data set. That's the very last one. So it's reduced variability caused by a single uh, train test split. That is the very first one. So limitation, more computationally intensive. Yeah. So as you can see, just one model, you train it on 4 different data sets. So it takes a lot of time, computation intensive. It will take much time, but you give you a good resource. All right. So that is all about the k-fold cross-validation. So with this one to look at how it computation is. All right. Thank you. So I would like to move to the next phase. Stratified splitting. For those who have done statistics, I think you can remember this word as a course or as a program. Stratified sampling. So we have probability sampling and non-probability sampling and all that. So stratified sampling. Stratified splitting is a method that divides the data set into training and testing. Also, yeah, multiple fold in cross-validation whilst preserving the proportion of each class with these sets. So we'll look at an example why we talk about this particular one. For what I'm reading, you might not get it, but we'll look at the example soon. In data sets with imbalanced class. So when we talk about data set with imbalanced class, it means that we have, let's say, positive or negative kind of information. So where one class is much rarer than the other. Okay. So regular random splitting might result in training or testing sets that do not accurately represent the overall class distribution. All right, so what is the limitation? More computation intensive. All right, so basically what this is saying is, let me move to the next page. So the example is this. Suppose you have a data set with 1,000 samples where 900 are negative cases and, oh, sorry, 900 are negative cases and 100 are positive cases. All right. You cannot put these two information together and say you are splitting 70 and then 30 or 80 or uh 20. No, because the negative itself is 900 and the positive cases are also what? 100. So in this case, you need to split the the 900 separately and then the 100 to separately. So the training set will retain approximately 90%. So this will take 90% and then a 10% from the positive. All right. Then the testing set will also maintain this same ratio. So you take 90% from the negative, then take 10% from the positive for the training. Then when it comes to the testing too, you take the same proportion. In that case, you get good results. All right. So that's basically for stratification because we have two informations in the data set. So you have to go by this method of splitting. If not, you'll get more negatives and sometimes positive might not be selected. Okay. I think there's a message here. Question. Okay. The stratification, I'm saying that we have two information in the data set, two major information, negative and positive. So in this case, if you give a command that it should split 70 and then 70 for training and 30 for testing, you'll be surprised that now when it's splitting, it does it randomly. Yes, random selection. You will just give the command split 70 and then the other one will be 30 and it does it randomly. So because it does it randomly with probability in mind, when you put these two samples together for splitting, it will not surprise us that it can if only pick negatives for both testing and then training without having a positive case in the data set. All right. So, and it will be a worrying situation because we have two informations in the data set, positive and negative. So we have to make sure that we have the two in each of the data set, that is testing and training. So to avoid this confusion, we cannot use the previous splitting case. We cannot. So what we have to do is that we will take the negative, which is 900 cases, and give a command to give us just 90% out of the 900. Then we take the positive cases and then we give a command, give us 10% out of the 100 randomly. So that will be for the training. Then we go back and give a command, give us 90% of the negative and give us 10% of the positive. All right. Then that will be for the testing. So in this case, both the testing and the training have the same proportion in terms of negative and positive. Have the same proportion in terms of negative and positive. Yes. I hope you get it now. All right. Thank you. Ah. So we are saying that the data, no, sorry, it divides data into training and testing set whilst maintaining the same class distribution. So when we talk about distribution, it means that the proportion as the original data set, leading to let me say fairness and more accurate evaluation of the model, especially with class imbalance. Okay, so we refer to this data as class imbalance. Why do we say class imbalance? We have one case more than the other cases, but we want to analyze all. So we call it class imbalance. All right. Okay. Then the last one. The last one is not different from the first two. All right. It's not that different. So we uh hold one, hold out method. A simple split where a fixed portion of the data is hold out for testing and the rest is used for training. Okay. So randomly partition the data into two subsets, typically using a fixed ratio of 70% and a 30% for both the training and then the testing. Train your model on the training data set. After training the model on the hold out test set to assess how, okay, so it's the same as the very first one, but the code differs. So we'll look more into that. All right. So this is simple and it's quick, efficient for large data sets. So results can depend heavily on the splitting case. So it's not different from the previous one, the first two, especially the first one. All right. Okay. So we have gone through the uh, the four main ways of splitting a data set. So we now want to visit our classroom and see how best we can apply the splitting. That's what we are going to start with. How do we split? Starting with the very first one, which is train testing split, 70-30 or 80-20. Let's move to classroom. Thank you. Yes.
Yeah, my question has to do with the name, the method one. It
Uh-huh.
says train, test, and split. But if you look at the description, you first have to split, train, and test.
No.
So,
Okay. So you see, you train first, then you test. All right. So it's training and testing split. Training and testing split. All right. Okay. So you just have to accept the term that you have to first train the data, then you test. So we want to have a split for training data set and then a testing data set. That's all.
oh, okay.
All right. I think I'll see how best I can word it later on. Well, thank you. Okay, so we can move now to our R. So I hope you have all launched your R space. Once you have your R launched, we can begin. So we are looking at the splitting machine learning. Now, I hope you all remember the data set we used the other time. That is the empty car data set. But before we tackle that, we would like to introduce you to something we call the seed. Okay, so I'll post this there. You have to first set this. It's an inbuilt operating system that is going to help us to achieve all that we wanted. All right. Set that dot seed 123. Okay, so you have to have it in there before, so you run it and then it will help us to achieve all our results. All right. Okay. So we remember this data set data. Then we said M. We remember this. That's what we are still going to use for head. After this one, you can type them. So head M T. I think it's already there. All right. So we have this information, the very first 6 information. And I think I gave you the meaning of all this. So you don't have problem with that. Now, we would like to first of all know the dimension of this data set. So dimension is very important so that when it's split, you can know. So we have 32 by 11. The 11 is for this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The 11 is for this, the column. Okay. The 11 is for this. When it counts, is 11. Then the 32, it is for the horizontals. That is this up to 32. All right. So we have 32 by 11. Now I want to split using the very method 1. I want to split. All right. So to split, I will first have to, as I said, there's no need to memorize the code. You can have the code. So I'll send it to you when I'm done demonstrating. All right. So we have the training index. So this is what I'm referring to as my training data set. So sample, sequence, then n row of the data itself, which is here. Then the size, 0.7. The 0.7, as you all know, is means 70%. Okay. Then the n row of the empty cars. So I'll run this, and then I will say print. We cannot run away from print. Normally, I have to copy this. I don't want to type because sometimes typing, you end up making a mistake. So I'll run this. Now, what can we see? We can see that it has sampled the information for me. Now, what this means is that it means that when you check the whole data set, it has picked row number 31, row number 15, row number 19, row number 14, up to row number 17 randomly. Randomly. So now I want to view only the train data. So view train data set. So if I should run this, it will, okay. It will not view for me. So let me, because it's already a different data set. Okay. So what it means there is that it have picked randomly the rows Okay, row number 31 up to row number 17 randomly. So 15, 19 in that order. All right. Then I want to check n row the dimension of this data set. Sorry. I want to check the dimension of this data set. And then what the dimension? I can't see. Oh no. Okay. You should give me. Okay, so sorry. Let me. So I can view this. Hmm. Okay. So it's okay. So please, just a moment. I'm coming. Okay, so then, all right. So I have this. Let me pick this one from there. I have splitting the data into 70%. So I will come by this and run this to help me split the data. So I have this, and then I have the data set. Yes, I have the data set. All right. So this is for the training data set. And this, I have printed it out. Then I want to know the number of rows. So the row is 22. So out of 32, it picked 22. Out of 32, which is for both training and testing or the entire data set, it was able to pick 22, meaning we are left with 10. So basically 10 will go for the testing data set. So I'm forwarding this information to you. Then please you run it and see if you get the same results. Once you are able to achieve what I have, then please you can send a message in the message box. Thank you. We move on to the testing data set. So all that we need to do is to just copy in the training data set, and then we change this to 30. Then what we need to do, this will be called test. This will also be called test. And then this will also be called test. All right. Then we have to just negate this. Why? Why are we negating this? We are negating this simply because it is here. And this is referring to the 70%, which is for the training. So when you negate it, it means that pick the 30. That's the meaning. I'm taking it again. With the testing data set, it's not different from the training data set. So the only difference is that obviously you know that the name will change. It will be testing data set now, but the source of the data remain the same. Then this training underscore index will be negated. Why? Because from source, you could see that this training index was assigned 70%. That's 0.7 of the number of rows for cars. All right. Then it means that there's 30% somewhere. So to get that 30% for assignment, you have to negate the training index so that it will pick the 30% and leave the 70% behind for this. So in this case, we have splitted the data. So if I should run this, it will give me my results. So this is the 30% I'm referring to. I would like to know the number of rows for the 30%. If I should run this, it tells me 10. And it's obvious because the training was 22. Definitely the testing will be 10 rows. Putting the two together will give me my 32. No data is left behind. Thank you. So if you have any questions, please you can ask before we proceed to the next phase. So do the editing and let me see if you can get the same results based on what I've just said. I know Gifty will be done. Yes, I know. Belinda, I'm waiting for her. Eugene. Eugene too is another guru in data science. Amma Abe. It's only okay, Abe. Abe too is done. Getting the good results. In fact, you are making the class so interesting. All of you, those sending the feedbacks, you are making the class so interesting. I really appreciate your contributions. Yes. The one using the phone. I think another time you can rename, you can give us your actual name, eh? All right, but we appreciate you too. All right. Okay. All right. Thank you so much. Thank you so much. So this is for the first method. This is for the first method. So we would like to proceed to the second one. We would like to proceed to the second method. Let me see. Somebody has sent a message. Okay, Isaac Tutu. Okay. Um, so with the second approach, we will have to call this library. If you don't have it, then you have to install it with the package. So please check if you have this installed. That's why we did installations a lot. So I will call the library. Yes, it's there. So you call the library. It should show something like this. Then it means you are ready to go. So it is similar. It is similar, but let's see, something will happen here. Here too, the seed will be used. All right. Now, the training index. So what is the training index? You see that the training index is the same as this training index. All right. But what continues is not different. The continuation is different. Okay. So now look at this. We have this. So we have create data partitioning. And as you can see, it's 70%. So if I should run this and then run this, then print it out, I have this information randomly. Okay. But I would like to know the number of rows. This time, the number of rows is 24. But the previous one, it picked only 22. So let's see what the testing data set will give us. Okay. I think the input, everything here is the same. So let me just copy this and bring it here. No difference. Just that it is based on this information. So if I should run this, it gives me 8. So each method and the number of rows that it will give you. So 8 plus 24, and that will give me 30. Yes, 32. All right. So I'm sending this all together. See if you have the same results like mine, then we can proceed. Thank you. Any other, please, so that we can proceed?
The other person can also do the same thing.
Who?
Xiaomi, or he's not the one. Someone is also complaining.
Yes, yes. The one is with the phone. What's his name? Is it Naomi or what? Xiaomi? Please follow the same.
Xiaomi.
Uh-huh.
It's Xiaomi phone.
Xiaomi. Okay, okay, okay.
Yes.
All right. So how far? Talk to me or talk to us. Now, Joanna is my co-assistant. Is he okay now with you? Okay, R2s is required. Yes, you can install R2s. Okay, you can copy this and then come here and install packages. Then you say R2s. Let me see. R2s. Then you can install. All right.
Doc, please, I can copy what? I didn't see what you were showing.
Oh, you can go to the message box. There's a statement saying R2s. It's also very important.
Okay,
Yeah,
okay,
R2s. Just copy it and then put it in the
okay,
tools, install packages, and then install. Okay.
okay,
All right.
okay.
Uh,
But I can't see that message. I don't know if you can resend it to me again.
Isaac. Okay, let me put it back into the message box.
Yeah,
All right, it's there now. So just copy
okay,
R2s
thank
and install. Yeah,
okay, thank
it's
you.
also very good. Okay. What's the name? I think Jessica. Yes, I've seen you. Well done. Okay, I think we can proceed. For Mark, I can't tell. Mark, I cannot tell. So please, that one, Mayo, Obojida. I cannot tell. So, uh, okay. Mm-hmm. What the thing? Wabuna sure. I'm getting some more Chinese words.
What does that mean?
Oh, I mean, I don't know for Mark. All right, let's proceed. So we want to move to another important thing on the same splitting issue. That is another way of splitting the same simple case. So we are still with the simple case. Huh. We are still with the simple case, but we are trying to uh, follow gradually to get the full understanding. So with this one, we have to install this package.
Doc,
Cat tools, yes?
I think the guy using, I don't know if it's a lady, using the Xiaomi. He said he's using online Jupyter, so he has not installed the R Studio, the main software. I think he's using the online one, so I don't know how if it's the same.
Oh, it will be difficult. I don't know. I have not tried that one. I think I've used it so many years ago, but right now we are all using the one installed on our machine, so I don't know. Okay. Hey, online Jupyter. No, then you have to use the R Studio Online. We have the R Studio Online. All right. So, Gifty, thank you for prompting us. Okay. So please let's install this. I don't know. You can check. You will need this tool. All right. You will need this tool first. So first of all, check if you have it installed. Then once you have it installed, then we can proceed to the next phase. Okay. So what it means is that you just focus on the very first one. These are different methods. So if the first one worked for you, just focus on it and leave the second and third. All right. Okay. So let me see. So once you have run it, then we can now look at this. Let's see how different is this one. So split. So in this case, we are using split. Split sample.split. Empty cars. Then I'm focusing on this. Then the ratio is 70%. That's 0.7. Split ratio. So if I should run this, then when I come to train data set, then I have subset empty cars, then split is equal to true. So it means that this is for the 70%. Then I would like to check the row. It's 22. 22. So it means that this is similar to the very first one, which is also 22, but the random process will be different. The random process will be different. That is the unique thing about the splitting. When I split mine, the random process will be different from yours. Okay. Just that we don't have time to check it manually. So once I have this, then it means that I can proceed to the 30%. All right. So with this one, it is not like the first one whereby you have to put negative, but rather you just say false. One is dealing with true and one is dealing with false. Yeah, and another thing is that the training would change to testing or test. Train would change to test. Then everything stays the same, with exception of the true changing to false. So if I should run this, then I'll have this print, and then I'll have 10. So you agree with me that 22 plus 10 will give me 32. So this is what we refer to as the splitting process. I think this one, in fact, research have shown that it is very good for classification. It's very important. So I'm sending it to you so that you can run same. Thank you. So now that we have seen the very first one, that is this. Now that we have seen this, that is the very first split, we are going to proceed with this. Then when we are done doing all that we want to do, we will now come to how to split with this. Then it will follow the same procedure. All right. Okay. So the k-fold cross validation, the stratify splitting, and then the hold out method. Once we know what follows after train and test split, we can come back to this and then we'll apply them to it. So let's proceed to the next item. So I will be taking you back to the regression. We want to fit a model. So step one, we want to fit a model. So we are fitting a model. Now this is a linear model, but this is a multiple regression model. Why is it multiple regression model? It's a multiple regression model because one, it has this as independent, and then it has this as independent. So this is the dependent. So it's multiple. Now, data set. So data, I'm using the training data. Now look at this. Because I just run this recently, this will be the current one I'll be using. If I want to use the very first method, then it means that I have to come and run this so that you have this in mind, this split. So let me run this. So you're using the very first one and run this and run this. Now this is registered in the mind of the machine. So it means that anytime I'm referring to training data set, it will give me the one with the 22. If I'm referring to the testing data set, it will give me the one with the 10. Okay, so let me come back to this. So I'm using training. So this is training data set. So it means that we are using the one with the 22. So even if I should pick this, if I should highlight this and run, and then let me say print, or no, end row, just to be sure that this is 22. Yes, it's 22. So it means that we are using the very first one. Okay. So I'm running this. So let me put this on it. I don't need it now. Okay. Okay, so if I should run this and print, I will have this information. So this is the model. This is the model for the weight and then the horsepower. For the weight and then the horsepower. So please, I'm sending this information to you. Step one. But you have to run the very first data set. No, the very first method that we use. Okay. All right, Gifty, thank you. All right, thank you, Ima. All right, so once we have been able to run, and then we know the coefficient of the independent variables and then the intercept. We cannot predict. We cannot predict. All right. We cannot predict. So the step 2 was for the output. So the step 2 is the output. So move to step 3. Step 3 is the prediction. Step 3 is the prediction. So we want to predict. So I'll explain the code, then I'll send it to you. Now, you said prediction. Then we quote the model, predict model. So the name of the model will be here. The new data set, you can see new data set, and the new data set is the testing data sets. New data set. So here it will be testing, unlike the model itself, which is the trained data set. All right. So once I run this and I print this, I have done my prediction. I will explain further when you also get here. So I'm sending you the code, and let's see whether you get the same output as mine.
Dr. Bernard, I just want
Yes, Dr. Koko.
to you. Please, can you hear me?
Yes, we can.
Okay. I just want to say a very big thank you to your dedication, the fact that you've been dedicated to this course, and really appreciate everything. And I believe the participants are also in agreement with me. Yes. And I hope that next session we'll have a wonderful and enjoyable learning period.
Sure.
Yes.
I really get it. Obviously, yeah, Didi. Yeah, Emmanuel, what are you saying? All right, so
Somebody
thank
says, do it, do it, do
Ah,
it.
do
Yes.
it, do it, do it. Oh dear, say now what you will do it. Oh dear. All right, so please, thank you. All right, I really appreciate. So let's practice and then let's prepare God willing on Friday. I really appreciate. Thank you so much. Thank you for coming. All right. So bye for now. Thank you, Dr. Koko, and thank you everyone.